Welcome to Spaceverse, your portal to cosmic adventures. The Bepicolombo spacecraft has just completed its fourth breathtaking flyby of Mercury, sending back extraordinary close-up images of this fiery, enigmatic world. This latest encounter has provided us with a rare and spectacular view of Mercury's south pole, a first for our planet thanks to this incredible probe. During this remarkable flyby, Bepicolombo ventured into the enigmatic night side of Mercury, where the planet's shadowed hemisphere awaited its arrival. As the spacecraft approached, the sun began to gently illuminate the cratered landscape, creating a breathtaking transition from darkness to light. The spacecraft made an incredibly close pass, coming within just 165 kilometers, or a little over 100 miles, of Mercury's surface. This close proximity provided Bepicolombo with the opportunity to capture stunningly detailed images of the planet's rugged and dramatic terrain. These high-resolution visuals are not only visually striking, but also essential for scientists as they work to decode the geological history and evolutionary processes of Mercury. Just 4 minutes after reaching its closest approach on September 4, Bepicolombo was met with a spectacular view of a colossal peak ring basin. This impressive type of impact crater, known as a peak ring crater, is characterized by a ring of elevated terrain or peaks encircling a central depression, rather than a single central peak. The formation of these distinctive rings involves a complex interplay of geological processes, and intriguingly, the inner rings may have formed through different mechanisms compared to the outer ones. This unique site offers valuable insights into the dynamic history and formation of Mercury's surface, providing clues that help scientists piece together the planet's geological evolution. These stunning images and the unique features revealed by this flyby are not only a testament to the technological prowess of the Bepicolombo mission, but also a treasure trove of information for scientists. They provide a closer look at Mercury's dynamic surface and offer new insights into the planet's complex history. This is an exciting time for space enthusiasts and researchers alike, as each new image helps to piece together the puzzle of Mercury's past and present. Mercury's enormous craters, sculpted by the powerful impact of asteroids or comets, range in diameter from 80 to 205 miles. Each of these basins is characterized by a prominent ring of peaks that rises dramatically from their otherwise flat floors, giving them their unique name and adding intrigue to their formation and evolution. One notable crater is Vivaldi, named after the famous composer Antonio Vivaldi. With a width of 130 miles, Vivaldi's vast terrain was vividly captured by Bepicolombo. The spacecraft's close approach near the sunrise line highlighted the crater's landscape with striking shadows and enhanced its rugged features. A particularly interesting detail about Vivaldi is the noticeable gap in its ring of peaks. This gap is the result of more recent lava flows that have entered and reshaped the ancient crater. This feature not only emphasizes the dynamic nature of Mercury's surface, but also provides valuable insights into the planet's volcanic activity and geological history. Bepicolombo's detailed observations are helping scientists to understand how these features have developed over billions of years, deepening our knowledge of Mercury's past. Shortly after, Bepicolombo captured images of another impressive peak ring basin, measuring 96 miles in diameter. This particular crater held special meaning for the mission team. Upon request from the MCAM team, this ancient crater was named Stoddart, in tribute to Margaret Stoddart, a New Zealand artist celebrated for her exquisite flower paintings in the late 19th and early 20th centuries. Mercury's peak ring basins continue to captivate scientists and enthusiasts alike, largely due to the many mysteries surrounding their formation. The prevailing theory suggests that these rings of peaks are formed through a rebound process during the impact, where the intense force of an asteroid or comet causes the surface to bounce back, creating a ringed structure. However, the precise depth from which the material was originally uplifted remains elusive, adding to the intrigue of these geological features. The images captured during this recent flyby of Mercury represent some of the most detailed views ever obtained by Bepicolombo. Taken during the spacecraft's closest approach, these images showcase Mercury's surface bathed in sunlight, revealing a landscape that has been profoundly scarred by 4.6 billion years of relentless bombardment from asteroids and comets. Each crater visible in these snapshots provides a unique glimpse into the planet's tumultuous history, telling stories of ancient impacts and geological upheavals. It's essential to recognize that these extraordinary images are a delightful bonus rather than the main goal of the mission. The MCAMs, which captured these detailed views, were not originally designed to focus on Mercury itself. Instead, they were intended to monitor the spacecraft, especially during the critical phase immediately following its launch. These cameras have provided black and white snapshots with a resolution of 1024 by 1024 pixels, which, while impressive, are not the primary highlight of the mission. The true excitement lies ahead. Bepicolombo's main science camera, which has been protected during the spacecraft's journey to avoid any damage, is set to offer much higher resolution images once it reaches orbit. This camera will provide an even more detailed and comprehensive view of Mercury's enigmatic surface, potentially unveiling new insights into the planet's geology and history. As Bepicolombo continues its mission, these forthcoming images are anticipated to enhance our understanding of Mercury and contribute significantly to our knowledge of the inner solar system. Launched in 2018, the Bepicolombo spacecraft is scheduled to enter Mercury's orbit in November 2026. This extended journey often prompts a familiar question: why does it take so long to reach Mercury, especially when spacecraft like Cassini managed to reach Saturn, over 1 billion miles away, in a comparable time frame? The answer lies in the unique challenges associated with reaching Mercury, which involve 3 significant factors. First and foremost, there is the issue of high initial velocity. Upon its launch from Earth, Bepicolombo inherited the substantial momentum from Earth's gravitational pull, resulting in a high-speed trajectory. To be captured by Mercury's much weaker gravity, however, Bepicolombo must significantly reduce its speed. This deceleration is not straightforward and involves a series of complex maneuvers and multiple flybys of other celestial bodies to gradually adjust its velocity. The second major challenge is the Sun's gravitational influence. Given that Mercury orbits extremely close to the Sun, Bepicolombo is continually pulled toward the Sun's powerful gravitational field. If the spacecraft were to fly directly to Mercury, it would require an impractically large amount of fuel to slow down sufficiently and avoid being drawn into the Sun. This necessity for a carefully planned trajectory to counteract the Sun's gravitational pull further complicates the mission. Lastly, as Bepicolombo approaches the Sun, it must contend with the intense heat that poses a significant challenge. The spacecraft is exposed to extreme temperatures that could potentially damage its sensitive instruments. To mitigate this, Bepicolombo is equipped with advanced thermal shielding and cooling systems designed to protect its delicate onboard instruments. These sophisticated systems are crucial for ensuring that the spacecraft can operate effectively despite the harsh environment. The need for such extensive thermal protection adds another layer of complexity to the mission, making the engineering and design processes even more demanding. Bepicolombo's journey has been marked by a series of important flybys, each playing a vital role in adjusting its trajectory and velocity. The Earth flyby on April 10, 2020 was a major milestone in the mission. This maneuver was not only a critical moment, but also a key opportunity to modify the spacecraft's path towards the inner solar system. By coming within approximately 12,000 miles of Earth, Bepicolombo was able to reduce its velocity by about 3 miles per second relative to the Sun. This significant reduction in speed was achieved with the help of Earth's gravity and saved around 450 kilograms of propellant, an essential fuel-saving measure that is crucial for the mission's long-term success. Following this, on October 15, 2020, Bepicolombo conducted its first Venus flyby, which was another crucial maneuver in its journey. During this flyby, the spacecraft utilized Venus's gravity to further refine its trajectory towards Mercury. By carefully maneuvering around Venus, Bepicolombo was able to adjust its speed and direction in a manner that conserved energy and ensured it remained on the correct path. This flyby was not only a key adjustment point, but also set the stage for the second encounter with Venus, which would provide additional opportunities for trajectory refinement and continue the spacecraft's journey towards its final destination. On August 10, 2021, Bepicolombo performed its second Venus flyby, and this time it captured something truly extraordinary. As the spacecraft zoomed just 340 miles above Venus's surface, it recorded the sounds of the solar wind interacting with the planet's thick, carbon dioxide-rich atmosphere. Using its magnetometer, Bepicolombo translated these interactions into an audio file, a fascinating sonification that gives us a unique audio glimpse into the cosmic dance between the solar wind and Venus. Following this, Bepicolombo achieved a major milestone with its first flyby of Mercury on October 1, 2021. This flyby, where the spacecraft came within 125 miles of Mercury's surface, was a huge success. It provided stunningly detailed images and crucial data about Mercury's geology, marking the first of 6 planned encounters. This flyby was essential for fine-tuning the spacecraft's trajectory as it headed closer to its final orbit around Mercury. The excitement continued with Bepicolombo's second Mercury flyby on June 23, 2022. This close encounter, where the spacecraft passed at just 120 miles above Mercury, allowed it to capture even more detailed images of the planet's surface. It also helped to further adjust the spacecraft's velocity, bringing it one step closer to its ultimate destination. Each of these flybys has been a critical step in Bepicolombo's mission, unveiling new secrets of the solar system's inner workings. On June 19, 2023, Bepicolombo achieved a significant milestone by executing its third flyby of Mercury. During this close encounter, the spacecraft approached within a mere 147 miles of the planet's surface. These close flybys are instrumental in refining the spacecraft's speed and trajectory, gradually positioning it for its eventual orbital insertion around Mercury. Each pass brings Bepicolombo closer to perfecting its orbit, making these maneuvers critical for the mission's success. Initially, the spacecraft was on track to enter Mercury's orbit in December 2025. However, on May 15, 2024, the European Space Agency shared some unexpected news. A technical issue had emerged on April 26 when a malfunction in the spacecraft's thrusters led to a reduction in their performance. This glitch impacted Bepicolombo's trajectory and progress, causing some concern about the mission's timeline. By September 2, 2024, the agency updated the public on the steps being taken to address this setback. They announced that a new flight path had been devised to navigate around the problem caused by the reduced thrust. This adjustment was essential to ensure the spacecraft's safe arrival and successful insertion into Mercury's orbit. As a result, the mission timeline has been revised, extending Bepicolombo's journey by an additional 11 months. The anticipated arrival date has now shifted from December 5, 2025 to November 2026. Despite this delay, these proactive adjustments are crucial for ensuring that Bepicolombo can continue its groundbreaking mission to study Mercury, overcoming challenges, and paving the way for future discoveries. The Bepicolombo mission is poised to unravel a host of intriguing mysteries about Mercury, which remains one of the least understood planets in our solar system. Among the primary goals of the mission is to shed light on Mercury's enigmatic magnetic field. Unlike Earth, which boasts a robust magnetic field, Mercury's magnetic field is comparatively weak. By studying how Mercury maintains its magnetic field despite its small size and less intense magnetic dynamo, scientists hope to gain crucial insights into planetary magnetism. These findings could illuminate how magnetic fields develop and evolve in rocky planets, potentially reshaping our understanding of planetary science. Another significant question that Bepicolombo aims to address concerns Mercury's unusually high density. The planet is known for its massive iron core, which constitutes about 85% of its radius. This disproportionate core raises questions about the planet's formation and evolution. Was Mercury formed through a unique process that differs from other planets in our solar system? Investigating the formation and composition of Mercury's dense core could provide new perspectives on how rocky planets develop, contributing to broader theories about planetary formation and structure. In addition to its magnetic field and core, Mercury's surface composition and geological history are also subjects of fascination. The planet's surface is marked by a history of volcanic activity, tectonic shifts, and mysterious hollows. Bepicolombo will conduct detailed analyses to uncover the secrets of Mercury's surface features. Understanding these geological processes will offer valuable insights into the planet's volcanic past, the nature of its tectonic activity, and the formation of its surface features, helping scientists piece together Mercury's complex geological narrative. Furthermore, Bepicolombo will investigate Mercury's delicate exosphere and its interactions with the solar winds. The planet's exosphere is extremely thin, composed mostly of atoms and molecules that are easily stripped away by solar radiation. By examining how this tenuous atmosphere responds to the solar winds, the mission aims to enhance our understanding of how planets with minimal atmospheres behave under the influence of solar radiation. This research could not only reveal more about Mercury, but also provide insights into similar planetary environments across the solar system. Through these ambitious goals, Bepicolombo promises to provide a comprehensive view of Mercury, enhancing our knowledge of this enigmatic planet and offering valuable information about the inner workings of the solar system. And that's it. Thanks for tuning into Spaceverse. We explored Bepicolombo's Mercury mission from its flybys to its core mysteries. Don't forget to like, subscribe, and hit the bell for more space updates. Keep looking up.